Okay, so looking at 411 now, area of a sector. So moving on from last exercise, which was looking at arc length, we can also find the area that's made by the sector that produces the arc length, or as you can see, that area in the circle there highlighted in blue. So again, we're given our formula, which is pretty straightforward. So area equals a half of radius squared multiplied by our angle there. So this will be on your cheat sheet, same as the length of the arc formula for your HSC. So I guess, yeah, it's just about knowing and then obviously being able to plug in your values and solving. So yeah, so nothing too much to discuss here. The formula itself just looks at the relationship between the angle and radius and the area of the arc that it produces. So let's have a look at how we can apply that calculation in some questions here. So a couple of more simple questions. Here we're asked to find the exact area. So that tells us that we need to find in regards to radians or pi radians. So we're not going to solve to get a decimal. We're going to leave it in pi radian form. And we're given a radius of 7 millimeters and this subtended angle here, which is in degrees. So again, in diagram if we drew a diagram, this is what it would look like. So we've got a radius of 7 millimeters here. Our angle subtended is 45 degrees. So considering we need an exact area, that hints that we need to first change this degrees value to a radian value. So I'll do that over here first. So I've got 45 degrees. To change it into radians, I'm multiplying it by the fraction where radians was on the top. So by pi on 180. So I get my fraction of 45 pi on 180, and then I just simplify through and say that 45 fits into 180 4 times. So pi on 4 is my subtended angle, and I'm just going to swap that out here because it's much easier when we're dealing with pi radians than we're dealing with degrees. So pi on 4, that's a terrible 4. Let's make it look a little bit neater than that. Pi on 4. Excellent. So now I've got my angle in radian form. I can now simply plug it into my, my formula. So area equals a half radius squared angle, or theta. So I'm going to plug in my value. So a half of radius is 7, so times 7 squared times my angle, which is pi on 4. I can multiply through, so multiplying the numerators, 1 times 7 squared is 49. 49 times pi is 49 pi. And multiplying the denominators, 2 by 1 by 4 gives 8. I'm fairly sure. Yep, and I look and I cannot simplify that because there is no common factor in 49 and 8. So that must be my answer there. So the exact area and in its exact form is 49 pi on 8. If I wasn't finding exact form, I could just plug 49 pi, divide 8 and calculate it to get my decimal value in radians. But we're asked to find exact area, so let's leave it in what it's asking. Okay, another simple-ish kind of question. Find the area of the sector correct to 2 decimal places. So here we're going to be finding it in, or the radian form in decimal, given the radius and a subtended angle. So this angle here is in radians already, so I can just simply leave it in that when I'm plugging that into my formula. So I'm going to use, again, my A equals half radius squared theta. Therefore, that equals a half times 3.21 is my radius, and 1.22. And that's just a simple calculator. And I should hopefully get 6.29. So 2 decimal places, 6.29 centimeters would be my units. So yeah, so not too hard as of yet. I've got a couple, well, let's have a look at a little bit of a harder question. So find the area of the sector of a circle with radius 5.7 if the length of the arc formed by this sector is 4.2. So this is similar to the second question we looked at in the last exercise. So I've got my circle, I've got my sector here. It's got a radius of 5.7 centimeters. And the length of the arc, so we're not given the subtended angle, so that's unknown theta. Length of the arc is 5.7 centimeters. Oh, wait, sorry. No, that's our radius. The length of the arc formed by that sector is 4.2. Okay, so before I can use, or let's have a look. So my area formula, which I'll need to use to find the area, half r squared, don't really need that, half r squared theta. So if I have a look, I'm actually missing a value. And my unknown value I need to find is theta here. And I can use my length of arc formula, because I'm given the length of the arc, to then derive theta, because I'm given my length of the arc and my radius, meaning I'll only have one unknown. So I must find this theta value before I can now equate the area of that sector. So going back to last lesson, L equals, or length of radius, length of arc equals radius theta. So length of arc we were given as 4.2 equals 5.7 theta. So therefore theta simply equals 4.2 on 5.7, which will give me okay, and it doesn't say, well, it doesn't say anything about needing an exacta or anything form, so I'm going to leave it in its decimal form. So 0.74 pi radians. Okay, so now I've found my theta. I can plug that into my original formula, and I can solve to find my area. So area, so now we'll only have one unknown, equals a half times radius, which is 5.7 squared, times theta, which is 0.74. So again, I'm just going to plug this into my calculator to get my answer. Okay, and I get 12.02. Okay, now the answer in the textbook is actually 11.97. And the reason why I got it slightly different is just because I rounded this number here. So if I would have left that in its fraction form and inserted this in here instead of 0.74, I should get that 11.97. So let's do that quickly, just to be exact. So I'm going to insert that fraction in here. So 4.2 on 5.7. Yep, and hopefully that gives me my 11.97. Let's have a look. Yep, exactly, 11.97. And we're talking about square meters, so I must make sure that I put on my units squared. So in this case, we were dealing with centimeters, so it'll be 11.97 centimeters squared. Cool, and one last question to finish off, quite a challenging question, one of the last ones. So let's work through it, and the other questions I'm fairly sure are quite similar to this one, so hopefully this helps you out if you're struggling later on. So we're asked to find the area of the sector of a circle with radius of 4 centimeters and angle subtended is pi on 4. So we're finding this entire area here of this sector. So let's go through and find that. So let's use our area formula, which we now know. So equals 1/2 times 4 squared pi on 4. The question doesn't ask if it wants an exact value either, so we can assume that we can just safely do a decimal. 4 squared, 16 pi on 2 times 4 is 8. So that would simplify it down to 2 pi, which we can leave as 2 pi. That's our radian measurement. Yep, let's leave that as 2 pi. So that's part A. Okay, part B. Find the length of BC, correct to 1 decimal place. So length BC would be the bottom of our triangle up here. Knowing that's a triangle, that was 4, or that's the radius as well. So that would also be 4 centimeters. So again, going back to the last exercise, I can do this in 2 ways. I can either split it in half and work out the length of a right angled triangle and double it, or I can use the sine rule. So it doesn't really matter, it just depends on what one you're most comfortable with. So let's use the sine rule. I probably would prefer to use the sine rule. So pi on 4, I know that pi is 180, so 180 on 4 would mean that the angle in that triangle I know is 45 degrees. So this would be 45, which means 180 take 45 would mean the other 2 angles must add to 135 degrees. So I'm going to halve that, and that will give me that these 2 angles are 67.5 degrees. So I want to find this length BC, so I'm going to put my unknown on there. So 45 reflects A, and 67.5 reflects 4. So plug this into my sine rule now. So I can get, solving for a side, A reflects sine 45 as 4 reflects sine 67.5. Solve for A, so A equals 4 sine 45, sine 67.5. So the length BC should equal, plug this in the calculator, okay, so as I plugged in the calculator, I got a negative value, which now we must use our knowledge to say that's impossible. So I must be in the wrong mode. I must be in radians mode still, which I am from that last question. So when I go ahead and put sine of a degree amount, it's assuming that that means 45 pi radians, and that's why it's throwing my answer completely off. So make sure you're in the right mode, change it back to degrees, and now I should hopefully get a more realistic number. Okay, so that's better. So 3.1 decimal place, so 3.1 centimeters will be that length BC there. So that's part B found. Okay, next we're looking at part C. We want to find the exact area of triangle ABC. Now, exact area hints that we're going to need to leave it in terms of pi radians, or maybe we don't need to. See as we go. So question part C. Did someone want to ask a question, or? I'll just keep going. So find the exact area of triangle. So found the area of the sector. Okay, so finding the angle, the exact area of triangle ABC. Circle. Okay, so just give me 2 seconds. Okay, so reflecting back on our area of a triangle formula, which was a couple of exercises ago. So we've got half AB sine C, where A and B, or where sine C is our length A there that we've just found. And then A and B sides are our 4 centimeters. So let's use this color. So this is going to be length C, which means that that's angle C. So we know the length C, and we also know angle C. And then we also know sides A and B as well, and they're 4 centimeters each. So let's have a look. So plug this in our formula. Area of that triangle equals a half times A, which is 4, B is 4 as well, times sine of angle C, which is 45 degrees. We know that. So plug this into my calculator and I should hopefully get my area measurement of that triangle there. So times 4 times 4. Again, making sure your calculator is in degrees mode, but it should already be in degrees for us. Okay, so I didn't realize, but we're asked to find exact area. So that's going to produce a decimal. So what I need to do is I need to figure out these numbers first. So a half times 4 times 4 would be 8. So 8 sine 45 degrees. And what I need to do now is I need to refer to my exact values using my exact triangles. So to get my exact value of sine 45, which you'll notice we can get exact values for sine, cos, and tan either of 30 degrees, 60 degrees, or 45. So I'm going to have to look back to my reference sheet, which should tell me my exact value. So I'll pull that up quickly. Okay, so sine is O over H. So we're looking at 1 on root 2. So I can substitute 1 on root 2 into this to find exact value. So let's use the other color. So 8 times, and sine 45 is the same as 1 on root 2. So I'm going to get 8 on root 2. Yes, sorry. All right, so that's our answer there. Moving on to part D, hence find the exact area of the shaded minor segment of the circle. So I'm going to have to use 2 of the measurements I've got already. So what I have here is I've found the area of the sector of this circle. So we're talking about that entire area. And I've also found the area of the triangle ABC. So what I can do for my sector if we have a look at the sector here, so I've got two parts. So I've got a triangle and I've got the extra bit. So if I take the area of this sector and I subtract the area of the triangle, it should leave me just with that area of the shaded minus segment. So that would be my minus segment there. So all I have to do now is take my two values and subtract them from one another. So my area of the whole sector was found in part A, or we're looking at 2 pi. And my area of the triangle was found in part C. So we're looking at is my 8 on root 2 and then I say, or I ask myself, can I simplify that? And not neatly, I cannot. So I should get 2 pi, take 8 on root 2 centimeters squared would be the area of the minus segment of the circle. Okay, so that one was quite tricky, but we did get there in the end. So again, just be careful of your exact areas. And we're looking for exact area here of the minus segment. So that would also suggest that we can't simplify this answer here either. So yeah, so good luck with 411. Finish the recording there.